Hello, and welcome to Tech Frontiers. Today, we're diving into the fascinating world of quantum computing, specifically focusing on something called quantum annealing and how it's starting to reshape engineering. For a long time, quantum computing felt like science fiction, but technologies like quantum annealing are quickly moving from theory labs into the real world, tackling problems that are incredibly difficult for even our best traditional supercomputers. So what exactly is quantum annealing? Imagine you have a really complex problem with countless possible solutions, like finding the absolute best route for a delivery truck, visiting hundreds of cities. Quantum annealing encodes this problem onto a quantum system. This system naturally wants to settle into its lowest energy state, much like a ball rolling downhill finds the lowest point in a valley. Here's the clever part. That lowest energy state actually corresponds to the optimal, or a very good near-optimal, solution to the original problem. What's become particularly exciting, especially with recent developments around late 2024 and early 2025, is that quantum annealers are showing they can find these high-quality approximate solutions faster or better than classical computers for certain types of problems. Why is approximate important? Because in many real-world engineering or business scenarios, getting a 99% perfect answer quickly is far more valuable than waiting ages for the absolute 100% perfect one. This ability to find great answers rapidly is a big step towards what we call practical quantum advantage. The applications are incredibly broad. Think about logistics, optimizing delivery routes, managing huge fleets of vehicles, or even coordinating those robot carts you see in massive warehouses. Quantum annealing thrives on these complex scheduling and routing puzzles. Or consider materials science. Quantum systems are great at simulating other quantum systems, like molecules. This means we can use quantum annealing and related techniques to speed up the discovery of new materials, maybe better catalysts for industry, more efficient battery components, or even help design new medicines. It doesn't stop there. Manufacturing can use it to optimize production lines and detect faults earlier. Aerospace engineers are looking at it for designing better aircraft using computational fluid dynamics or managing satellite constellations to avoid collisions. The energy sector sees potential in optimizing power grids and developing carbon capture technologies. Even telecommunications companies are exploring how to optimize mobile networks during busy periods. Now, we're often not using purely quantum systems yet. Many current solutions are hybrid, blending the power of quantum annealers with classical computers. Companies like D-Wave Systems are pushing the hardware forward, building annealers with over 5,000 quantum bits or qubits, improving how these qubits connect, and adding features like fast anneal to boost performance. There are also clever techniques like quantum annealing correction, or QAC, popping up to reduce errors. And while the hardware matures, researchers are also using simulated quantum annealing on classical computers as a stepping stone. Of course, it's not all smooth sailing. Building large, stable, error-corrected quantum computers is still a massive engineering challenge. Keeping qubits in their delicate quantum state, minimizing errors, and figuring out the best way to translate complex real-world problems into a language a quantum annealer understands are ongoing hurdles. But the momentum is undeniable. The focus is shifting firmly towards solving practical, industry-relevant problems. As the quantum hardware gets better and the algorithms smarter, quantum annealing and optimization are set to become powerful new tools in the engineer's toolkit, offering fresh approaches to problems that were once considered simply too hard to solve. It's an exciting time to watch this space unfold. That's all for this episode of Tech Frontiers. Join us next time as we explore another cutting edge of technology. Thanks for listening.